Hi everyone, in this video we're going to be graphing systems of inequalities with rearranging. If you're in Ms. Drake's class, we're on page 41 of your Unit 3 packet. Okay, so when we're given a system with rearranging, you first have to check to see if the inequality is in slope-intercept form. That's the way we were graphing them in yesterday's lesson. If not, you have to rearrange the inequality to be in slope-intercept form first, and then you're going to graph exactly how we did yesterday. So take a look at the two inequalities that were given. The first inequality is the same inequality from the do now. If you did the do now, we had to rearrange it to be in slope-intercept form. So we wanted to say y equals. So I'm going to rearrange down here. Okay, so I have 3x minus 2y is less than 10. So my goal is to get the y by itself. I'm going to move the x term first by subtracting 3x from both sides. Okay, I'll cancel those out. I'll bring down my minus 2y is less than 10 minus 3x. Okay, now I need to get rid of this negative 2 in front of the y, so I'm going to divide everything by negative 2. Divide this by negative 2, divide this by negative 2, and divide this by negative 2. Okay. My negatives 2's cancel, and I have y is, because I divided by a negative number, we have to flip our inequality sign, so that less than becomes a greater than, and then 10 divided by negative 2 is negative 5, and then negative 3 divided by negative 2 is not divisible, so we're going to leave it as a fraction. You could write it as a decimal, I guess, as 1.5, but I'm going to leave it as 3 over 2x. Okay, the reason I'm leaving it is because this is in slope-intercept form, and that's going to be my slope, so it's going to be easier to graph with that as a fraction rather than a decimal. If you want to rearrange it to have the slope come first, you would rewrite it as y is greater than 3 over 2x minus 5. But either one of these is fine to put into Desmos or to graph using the slope and the intercept. Okay, let's take a look at the second inequality. Y is less than or equal to negative x plus 1. Is that already solved for y, or do I need to rearrange? It's already in the form that I want, so I can graph from here. I'm just going to rewrite it on the side so that I can label which is my slope and which is my y-intercept. Okay, so I'm going to graph this one first. Okay, my slope is 3 over 2. Write that here. My slope is 3 over 2, and my y-intercept is negative 5. Okay, so that means on my graph, I'll start at the negative 5, 1, 2, 3, 4, 5, and my slope is 3 over 2, so that means up 3, right 2 from my intercept. So up 1, 2, 3 over 2. Up 1, 2, 3 over 2. Up 1, 2, 3 over 2, and up 1, 2, 3 over 2. Okay. Now take a look at your inequality symbol, and that's going to tell you a solid or a dashed line, and then which way to shade. So if there's no equal sign, should I use a solid or a dashed line? I hope you said dashed. Okay. And then because it's a greater than sign, will I shade above or below the line? Above. Okay, so use a straight edge or ruler of some sort. Connect with a dashed line. Okay, like that. Put arrows at the end. And then we're shading above the line. So like we saw in previous videos, we're going to use stripes for our shading. Okay, and then somewhere near the line, you're going to write a label. I usually do it off to the side when I'm doing two inequalities on the same grid. So 3 over 2x minus 5. Okay, let's take a look at this inequality. I'm going to switch colors just so my graph is a little bit easier for you to see. Okay, let's see. What is my slope? What is the coefficient of x? Negative 1. So my slope is going to be negative 1 over 1, so down 1. Right 1. And what is my y-intercept? 1. So that means I'm going to start my graph at the positive 1 on the y-axis. Here's my 1. Okay, and then my slope is down 1, right 1. So from here, down 1 unit, right 1 unit. Down 1, right 1. Down 1, right 1. Down 1, right 1. Okay, once you have a few points, you can use your ruler to connect your points. Look at your inequality to decide whether it should be solid or dashed. Hopefully you thought solid. Connect your points. Give me arrows on both ends. And then which way should I shade? Okay, it's a less than sign, so shade below the line. I'm going to use these stripes again for my shading. And then I'm going to label off to the side. Okay. Once you have your shading done, you're going to label the overlapping intersection with a big S for solution. So here's my big S. Okay, and just like in yesterday's lesson, we talked about any point in this double shaded region is going to be a solution to the system. Okay, so it says here to verify your solution by choosing a test point. So you can either look at the graph, and then over here I'm also going to substitute to show you how to check the point. Okay, so first I'm going to check 2, -2. Okay, so that's this point right here. Okay. Is that a solution to the system? Okay, well, let's see. It's on a dashed line, so do you think it's going to be a solution? No. If it's on the dashed line, it's not going to be included. I'm going to show it algebraically, because in your homework there is an example where you have to prove it algebraically. So I'm going to go to my original equation, or inequality. 3x minus 2y is less than 10. And I'm going to substitute 2 for x and -2 for y. So I have 3 times x, so 3 times 2, minus 2 times y, so 2 times -2 is less than 10. Okay, let's see. 3 times 2 is 6, minus 2 times -2, so that's going to be 4. 6 plus 4 is 10, is less than 10. Is that a true statement? No, 10 is not less than 10. 10 is equal to 10, so this is false. If it doesn't make both inequalities true, it does not make the entire system true. So I don't have to check the other inequality. Let's check the point -2, -2. So remember, it has to work for both inequalities to make the entire system true. So let's check the first one. 3 times x, so 3 times -2, minus 2 times y, so 2 times -2, is that less than 10? Okay, let's see. 3 times -2 is -4. This would be plus 4 is -2 is less than 10. Is this true? Yes. Since it's true for one inequality, I'm going to check the second one as well. So now I'm going to check this inequality. Is y less than or equal to -x plus 1? So is -2 less than or equal to the negative of x, so the negative of -2 plus 1. What is the negative of -2 plus 1? 3. So is -2 less than or equal to 3? Yes. So because it works for both inequalities, we know it makes the entire system true. And we can also look in the double shaded region, -2, -2. The point is right here where the two shaded regions overlap. And you know that it is a solution because it's in that double shaded region. Okay, so before you try the homework questions, let's do the 2 examples on the next page. Okay, you can check the answer key to match your graphs before you try the homework, and reach out to your teachers if you have any questions.